1001 questions. Why do male seahorses get pregnant? Unlike other marine creatures, seahorses have a very unique reproductive trait. The males are the ones who become pregnant and give birth to baby seahorses. Seahorses, also known as hippocampus, are a species found in tropical waters. They typically range in size from 16 centimeters to 35 centimeters. Seahorses are considered fish because they have pectoral and dorsal fins. They usually feed on small crustaceans like shrimp or fish by sucking them into their mouths. Seahorses can live in pairs or in groups. When living in groups, apart from mating in the morning or at dusk, they spend the rest of the time foraging for food. Seahorses are closely related to pipefish and sea dragons because in these species, it is the males that take on the role of pregnancy and giving birth, a task typically performed by females in most other species. However, instead of carrying the young inside their bodies like a womb, male seahorses carry the offspring in a pouch similar to that of a kangaroo. The mission of male seahorses is to become pregnant. There is a theory explaining why male seahorses carry the pregnancy. The natural design of male seahorses allows them to produce more baby seahorses at a faster rate. Meanwhile, the females transfer all of their eggs into the male's pouch during mating. This process takes longer for the female to recover and create new eggs. A male seahorse can give birth and immediately become pregnant again as soon as the female has accumulated enough eggs. This division of tasks allows the female enough time to recover energy and produce more eggs instead of simultaneously creating eggs and nurturing the young. Before handing over the eggs to the male for caretaking, the female uses her energy to provide nutrients to the eggshells. The male's role is simply to create a safe environment for the baby seahorses to grow. For seahorses to reproduce, they must first mate. The male and female will swim around each other, using their fins to flirt. This playful interaction can last for several days before mating occurs. Once they are ready, the female seahorse will swim towards the water's surface, and the male will follow closely behind. The female will then deposit bright orange eggs into the male's pouch through an opening at the top. After safely transferring the eggs, the male releases sperm and seals the pouch. The fertilized eggs then begin developing into baby seahorses. At this point, the female's job is done. The male now takes on the role of incubating and caring for the eggs. The male seahorse's pouch can regulate temperature, blood flow, and salinity to ensure optimal conditions for the eggs to grow. Male seahorses sometimes eat their own offspring. Baby seahorses are so small that they cannot consume plankton like their parents. As a result, their survival rate is very low. Furthermore, they are often swept away by ocean currents before they can latch onto rocks or corals for shelter. Many baby seahorses, unfortunately, become easy prey for other fish. Male seahorses refrain from eating for a few hours after giving birth. However, if the baby seahorses linger nearby, they may inadvertently become a tasty meal for their father. Indeed, male seahorses sometimes eat their own offspring. Similar to many other fish species, out of the hundreds of baby seahorses born, only a few will survive and grow into adults. Male pregnancy disrupts gender-related behavior. Evolutionary biologist Adam Jones and his colleagues at Texas A&M University are studying how the body structures necessary for male pregnancy evolved. The researchers hope to gain insights into the evolutionary mechanisms responsible for structural changes across species over time. Male pregnancy also causes a disruption in gender-related behaviors. Jones explains, female seahorses exhibit competitive behaviors typically seen in males, while males display choosiness, a trait usually associated with females. His team is also investigating the evolutionary steps leading to this behavioral reversal and the role of hormones in these changes. Another aspect Jones's lab is studying is the evolution of the seahorse's unique body shape. How do we trace the evolution of a species as unusual as the seahorse from more typical fish forms? Many evolutionary steps must have occurred during this process, Jones explains. The first step in this evolution was body elongation, which the team is currently investigating. The second step was the development of unique structural features characteristic of seahorses, such as their distinct shape. A seahorse's head is unlike that of most fish. It is perpendicular to its body. Seahorses also have a prehensile tail, meaning unlike other fish, they possess a tail capable of grasping objects.